Hello everyone, welcome to this session. This session is about Git, in case you have a chance to leave now, if this is the wrong room, okay? My name is Enrico Campidoglio. This is going to be a pretty technical session, so hold on to your seats and your coffees. It's called Git Hidden Gems. Now, before we start, I would like to ask a few questions. How many here are new to Git? Okay, one or two. How many here are intermediate Git users? Like you use it every day, but you haven't looked into the more advanced stuff. Okay, so that's most of you. And how many here are Git masters? Come on. I know there are a few. Yeah, okay, one. Yeah, two. All right. Okay, so my goal here today is to tell you at least one thing that you did not know about Git. And if for some reason you already knew everything I told you about today, then look me up afterwards, because we might have a hobby in common. All right, so what gems, you might ask? Well, isn't Git just a version control system? Well, yes and no. You see, Git is a bit like a Swiss Army knife. It's a tool that you know, that is of everyday use. However, it's also more than that. It has more features than you probably know about, and some of them are hidden below another layer that you don't always look into. And even if you find that feature, you might not know what it's used for. So yes, Git is kind of the Swiss Army knife of version control systems. And yes, I came up with this myself in the shower. So, before we move any further though, let me address the elephant in the room. What's with all this ASCII art? Well, you see, Git is a tool that was created at the command line, and it's meant to be used at the command line. Now, I know there are a lot of Git GUIs, some good, some bad, they do the job. However, if you want to unlock the full power of Git, you should be using it from the command line, and I'm going to prove you why that is here today. So yes, welcome to the terminal. That means that the entire presentation is going to be from the terminal, and yes, that even includes the slides. And you will not believe how long it took me to draw that. So let's look at it for a few more seconds, shall we? All right. What's the game plan? We have a canvas. We divide it into two parts. Now, on one side, my left, your right, or the other way around, I never get it right, we're going to have a local Git repository. On the other side, we're going to have some text and some more ASCII graphics to explain what's going on. Okay? And they're going to move along together, these two. Now, in order to do anything, we're going to need a project. Now, this is not important at all. But the project is a calculator. Not that it matters. We're going to not look at it like from a functional point of view. But it's a calculator, and it's written in Node, and it's written in TypeScript, because why not? So that's it for the preamble. Let's start with the first gem, which I call pretty logs. So here we have the repository on the left side or right side, depending on which side you're on. And you guys probably all know about git log. Pretty boring command, It shows you the commit graph, nothing really fancy about it. However, you might not know that git log has an option called pretty. Now, what this allows you to do is that it allows you to customize the output of the history. So, for example, if you just wanted to see the commit message, you would pass the option pretty and then say %s, which is a placeholder that stands for summary, which is the first line of the commit message. And if you do this, then you just get the commit message. Now, okay, you might say, but of course you can do much more than that. So for example, you can say git log pretty, and then you can change the color of the output to, for example, red. And then we want to print a commit hash. However, we don't want to look at the long commit hash. We just want the abbreviated one, which is usually 6 or 7 characters. So let's add the %h, which stands for commit hash. Now let's reset the color. Now let's change the color again to yellow. And now I want to print out any branch reference that's currently pointing to that commit. Now, if you had to guess, what's the placeholder for the branch reference? B, or any other guesses? R? Well, it's neither of them. It's D. Now you might wonder, why on earth is it D? Well, let me open a brief parenthesis here. That's because before, in early Git versions, so pre-2010, in order to print the branch references as part of your log output, you needed to pass the --decorate option. Otherwise, you wouldn't see them. So, for historical reason, the decorate, that's where the D stands for in order to print the branch references. So that's a bit of history trivia for you. Now let's reset the color again. Now let's add a space and let's print the summary that you already seen. Now let's change the color again, this time to cyan. Let's open a parenthesis. And now I want to print the commit timestamp. However, I want to print it not as an ISO timestamp, but as a timestamp relative to now. So I say author timestamp relative to now. And now let's reset the color again. And then I get this, which is much better. And of course, the possibilities are endless. And I mean, all you have to do to take advantage of this is type this string every time. I mean, as you can see, I got pretty fast at it. No, of course not. You can do better than this. You can use another feature in Git called aliases. Now, you might or might not know about aliases. Now, an alias is simply a word that you associate to a Git command together with a bunch of options. Now, of course, we can do that for this entire string. So we can create a Git alias for our pretty log. Now, let me just copy this string, because we don't want to type it again. And now we say git config global, because you want it on all repositories, not just the current one. And then you say alias dot, and then the name of the alias, so in this case, LG. And then you say, which command do you want to run when you invoke this alias? Well, I want to run log with the pretty option, and then I paste in the entire string. And now I can say git lg, which is what I've been using it for years. So that's my usual, I just type git lg. And then when I go to a new computer, I type git lg, and it says unknown command. So that's the blessing and the curse of using aliases, because your fingers get used to them, and then you go to a different computer, we don't have your aliases, and then nothing works. So, but it's really useful. Let's continue on with the second gem, which is called pretty diffs, to stay in the theme of pretty things, because if you are sitting on the terminal all day like I am, it might as well look good, right? It doesn't have to be black and white or green on black. So, pretty diffs. Now, you all know the diff command. So let's diff the previous commit to the latest one. And then you get this. Now, pretty boring. Everybody's seen it. However, everything that comes out of Git commands is automatically piped through another program called a pager. Now, the default pager in Git is less, which is a program that allows you to scroll up and down using the arrows or the J and K keys. However, it's not fixed. You can change it with a configuration setting. And that configuration setting is called core.pager. Now, the good thing to know is that there are programs out there that do pretty things with the diff output. There are a bunch of them. There is one called diff so fancy, which is, it says, it does what it says. And then there is another one called delta. Now, delta is written in Rust, which already there tells you that it's much cooler than the rest. So delta is currently my pager of choice. And how do you use it? Well, first you need to install it, which of course I already did, but it's pretty easy to do. Then you say git config global core.pager, and then you say that the pager should be delta. And now, if I run the same command again, I get this output. Now, what's cool about this? Well, you notice a few things. First, the plus and minuses have been removed because they're just, you can see them from the color green and red. And then you can also notice that we have syntax highlighting for your language in the diff, which is pretty cool. So I highly recommend you to use delta and set it as your pager. Now, let's move on. And let's start modifying files. Let's talk about staging. Now, it's always a good idea in Git to make commits that are semantically cohesive. What does it mean? It means that one commit should represent one logical change. For example, if you're making a refactoring, that should be one commit. If you're adding a feature, that should be another commit. Now, as you know, that's hard to do in practice, because when you're working, you might go in to implement a new feature, but then you see a refactoring opportunity, so you take it right there and then. So then how do you split that into different commits? Now, with other version control systems, that's pretty hard to do, if not impossible, unless you're really disciplined with doing one thing at a time. In Git, it's not like that at all, because in Git, you can choose your workflow, work as you like, and then use Git feature to have a clean history. So one of the features that Git has for these things is called the patch option of git add. Now, let's look at an example. So I have a file called index.ts, which is the entry point of this program. Now, let's open it up with the editor, the only editor that you will ever need. Which is it? Yes, but which text editor? Did I hear Emacs? No. No. What did you say, Vim? Oh, yes. Thank you very much. That's the editor that you need. The only editor that you'll ever need, actually. So, yeah, so let's open it up. It's a TypeScript file. Now, let's say that I spot a typo here. So, for example, this word over here, the word embarrassingly enough, has 2 R's. So here is a typo. So let's fix that. Let's make 2 R's over here. Now, I'm into this file, and then I look at the features of the code, and then I see that, yes, this string here, I like to change this as well. Because I want my calculator to be really academic. So I don't want to say the numbers to add. I want to say the addends instead. So now I made 2 changes. I made one change over here, which is, you could say, fixing a typo. And then I made another change over here, which is, you could say, kind of a new feature. Okay? So now what I want to do is that I want to stage that change, but I want to leave that in my local working directory. So I want to commit just the upper portion of the file. How do I do that? That's where the patch option comes in. So let's save this. And then I say git add patch. Now what Git does is that it asks me, do you want to stage this hunk? Now, the word hunk here doesn't mean what you think it means. In this case, it means basically in the unified diff format, which, believe it or not, is a standard, The word hunk means a portion of a patch. So it says, do you want to stage this hunk? And then you get a self-explanatory list of options. Which, of course, I mean, you can always type the question mark and then you get an explanation. But believe me when I say that what we want to do in this case is we want to split this into smaller chunks. So we want to type S. So let's say split. And then I get the same question. However, this time, it's one of two hunks. Can you see it here in the bottom corner? So do you want to stage this? And I say yes. Do you want to stage this? No. And then if I say git status, you see that the file is simultaneously staged and unstaged. Now you might wonder, how do I look at what I'm about to commit? I want to see the diff of what's being staged. Well, I can say git diff staged. And if I say git diff, then I get what is still in my working directory, but not to be committed. Bonus tip. This works also for undoing changes. Now, let's open it up again. Let's say that I am going to type this is documentation. And then over here, I'm going to make a comment. This is a comment. Now, I made two more changes. I want to undo one of the changes, like completely remove it from my working directory, but keep the other one. I can say git restore patch. And then I get the same question. However, this time it's about, do you want to discard this hunk? And then I say split. Do you want to discard this? No. Do you want to discard this? Yes. Do you want to discard this? No. And then I got rid of one of the comments, and then I kept the others. Okay? So patch works for staging, but also for undoing portions of a change that you have in your file. Pretty useful stuff. Did you guys know about this? Anyone new? Okay, a couple of you. Let's move on to more staging. Now that we have this situation over here, where the file is modified, but only a portion of it is about to be committed, now we have a problem, because when you commit things, you not only want them to be cohesive, you also want them to be consistent. That means they should not break the build. You should be able to confidently cherry-pick a commit or merge a branch and not having to worry about this is going to break the build or start failing tests. But how do you ensure that if you are to commit only the staged part, how do you know that that by itself doesn't break the build without all the other changes that you still have in your working directory? So in other words, how do you isolate that? Well, it turns out that the stash command has a useful option called the keep index. So what this allows us to do is that we can stash what we have in a working directory, but we want to keep whatever is already being staged. So now, if I say staged, I still have my change. And if I say git diff, I don't have anything. So I got rid of everything in my working directory, and I just kept the staged part. So now I know that that change by itself is going to be committed. And then I can, for example, run the tests and see that, of course, this works because it's just fixing a typo. But nonetheless, you can verify your changes isolated from everything else. And then at this point, I can make a commit. Let's say fixes a typo. And then when I'm done, I can say git stash pop and get back my changes from the stash. And here they are again. Okay? How many here are using this workflow? Okay, a couple of you. Cool, cool, cool. Pretty useful thing to know. Let's move on to searching. Now, Git has some pretty powerful searching facilities that allow you to search through the history based on the changes. Now, the most powerful probably of those search features is called pickaxe, because you imagine that you go spelunking into your history with your pickaxe. At least that's how I think about it. So what option is that? Well, you use it with git log, of course, because that's about looking at history. And the pickaxe allows you to look at, you want to find commits that either add or remove a line that matches a certain pattern. In other words, what commit added this code, or what commit changed this line? And the option for that is capital S. So in this case, I want to find the commit that originally introduced a typo. Okay? So I say git. Of course, you can use your alias. So I can say git lg s, and then you say embarrassing with 1R. And then I get 2 commits back. Of course, I get the commit that we just made that fixes the typo. And then I get another commit. Could it be the one that originally introduced it? So let's grab the commit hash, and let's look at the contents. Yes, indeed, that was the commit that originally introduced the line. Cool stuff. Don't need any fancy GUIs to look at to find commits based on the contents. Bonus tip, and this is going to blow your mind, I hope. At least it blew mine when I found out about it. You can also search by function name. What's a function? Well, it's whatever it resembles a C-style function. So a name and a bunch of curly braces, not a bunch, two parentheses and 2 curly braces. Doesn't matter which line they are. If it resembles a C-style function, Git is going to find it. And you can find commits that somehow touch a function. So the syntax for that is L. So you say, so for example, in this case, I have a file called calculator.ts, and this has a function called add, which indeed resembles a C-style function. Could have been C# method, could have been Java method, doesn't really matter. Now I want to say which commit somehow modifies this function. Then I can say git lg L colon the name of the function colon the path to the file that contains that function. So calculator.ts. Bam! I get the commit that added, in this case, the function. And if there were other commits that change anything inside the function body or the signature, they will also appear here. Did you know about this? Kind of new. Okay, this is pretty useful. One new. This is pretty useful stuff. So this is another point I want to make, that some GUIs might expose this functionality to you, but some others don't. If you're at the command line, you have the full capability of everything. I'm going to prove this point once more, at least in this presentation. So let's move on to automation. Questions afterwards? Yeah. Automation. All right, so there are a bunch of workflows that are very common when you're using Git. One of these workflows is, I just realized that the change I made now should have been part of a commit 10 commits ago. Has it happened to you? Yes, it's pretty common. Now, this is so common, in fact, that Git has a possibility that it allows you to make a commit and then make it part of a previous commit. You're rewriting history. You're doing something called squashing. You're squashing a commit into another one so that it looks like it's one. And another one is called fix-up, which is basically the same thing as squash, but you are reusing the commit message. You don't want to change the commit message. Now, this is so common that Git has a built-in automation feature to make it easier to do, which is called auto-squash. Now, what on earth is auto-squash? Well, you wouldn't know because it's off by default. And why is it off by default? I don't know. You tell me. But you need to enable it. So you say git config global rebase.autosquash. You set it to true. Now it's enabled. Now, how do you use it? Well, let me show you. We have, right now, a change that sits over here. We change the string, the numbers to add into the add-ons. Now, let's imagine that I would like to squash this commit into the commit that originally introduced the numbers to add, so that it looks like I wrote the add-ins from the very beginning. Okay? I want to rewrite history. Now, first, and if you haven't noticed already, I'm going to tell you now, these gems kind of build on top of each other. So as we progress, we're going to use previous tips and tricks to do more stuff. So right now, we want to find a commit that added a certain line. So we're going to use the pickaxe, for example, together with our alias. So we say git lg s, and then we find the string numbers to add. There it is. That's the commit that originally added that line. Let's grab the commit hash. Now let's use the patch option to partially stage the file and only stage that change, because remember, we have two changes now. We don't want to stage this one. We just want to stage this one. So we say no, and then we say yes. Now we know which commit we want to amend, and we have just staged the part we want to include. So now we say git commit -- fix up, and then the hash of the commit. Now what this does, it creates, of course, a regular commit. However, the commit message is made up of the string fix up ! So you can think of it as fix up. And then you have the commit message of the commit that is going to be squashed into. Now, once you have this, of course, and then you can, at this point, you could keep working with other things. You can make other commits. And that is going to be parked for later. Now, what's later? Well, later is an interactive rebase, where you want to move that commit below the one that's going to be squashed into, right? So let's do that. Let's rebase interactive. I'll probably just type -i. And then in this case, I want to include the entire history. So I say root, but in your case, it's probably going to have the branch point there. Ooh. And this happens. Have you ever had this experience? You want to do a rebase, but you have changes in your working directory. Yes, it happens. You might be surprised to know that Git has an automation feature for this as well, which is also off by default. And that is called, can you guess what the name is? It's called autostash. But please pay attention to the spelling, because it's capital S. If you type it with lowercase s, it doesn't work, and you don't know why. It happened to me. It has to be stash with capital S. So let's enable it. We say git config global rebase.auto-stash true. So now that we have enabled it, let's redo the same operation again, the rebase. Something happened, we're going to look at it afterwards. Now, what happened here? Well, just know that we could do the rebase even though we had changes in our working directory. Now, you see this commit got moved right below the commit that is going to be squashed into. And the action has been changed to fix up. Now imagine that you have a bunch of those fix up commits, and they, with one single rebase, they are going to be moved into the right position. So you basically do a bunch of fix up commits, and then you do one single rebase, and they all move to the right position, and they all get squashed. So that's pretty awesome. So in this case, I don't have to do anything, but just save the file and exit. I did the rebase, it got squashed, we're going to look at it, but look what happened here in the meantime. It created a stash, it allowed us to do the rebase, and then it reapplied the contents. So if I look at my working directory, here's my change. if I look at my stash, it's empty. No trash left afterwards. Auto stash and auto squash. By the way, let me show you our history now. And you see that we don't have the fix up commit anymore. And this one is the one that we squashed into. If you're wondering why I typed 45, are you wondering why I typed 45? I didn't mean to. I meant to write 4, which means show me the last 4 commits in git log. But then I slipped and I typed 5 as well. But that's also good to know, that you can say git log dash and then a number, and that it shows you just that number. So for example, if you just want the latest one, you can say git log -1, okay? So let's look at this commit. Let's look at the contents. And indeed, it says the addends. So we have successfully amended it. How many here knew about auto squash and auto stash? 1, okay. Let's change gears. By the way, spoiler alert, I have 9 gems. Why do I have 9 gems and not 10? Because when you're doing a presentation in the terminal, you want usually squares, because it's not easy to have round shapes. And 9 looks really good on 3 lines of 3 items. That's the reason why I have 9. So, dot notation. Have you guys heard about the dot notation? No. How about the dot notation? How about the dot notation? Yes. 1 in both cases. Dot is a real thing. It exists. But today we're going to look at the dot notation. 2 dots. What does it do? Well, it allows you to compare branches. So for example, let's say that we have a situation that looks like this. You have a topic branch and you have a main branch. It's usually your pull request branch, whatever. The question you want to ask when you're working in a topic branch is, what commits do I have in this branch that are not in the mainline branch? And on the other side, you want to also say, what commits does the mainline branch have that I don't have? So, what we want to basically find out these 2 commits. What commits are here that are not here? So how do you express that with the log command and the dot notation? You say git log, what commits are not here, but that are here. So in this case, let me change to a different branch. I have a branch called feature add test script. Oh, let's do. I have, of course, changes in my working directory that I don't want, so let me just force. Okay, so now we are in a topic branch. What commits do I have here that are not in main? So I say git lg, not in main, but in my current branch. And then I get this list. Now, the opposite is also possible, of course. You want to say what commits are in main that are not in my topic branch. So how do you express that? Of course, there is going to be the opposite. What commits are not in my topic branch, but that are in the main branch. So basically revert that. Git lg, not in my feature branch, but that are in main. And then I get those 2. Pretty useful stuff. Now it gets even more useful, it gets usefuler if you combine this with the aliases. Now imagine that I have an alias called new, for example, that basically says, show me the commits that are in my current branch, head, the branch I've currently checked out, that are not in master or main or default or whatever you call your main line. So let's add an alias globally called new that basically says LG, because another thing that blew my mind, you can have aliases that reference other aliases. Can you believe it? That was not possible in Git 1.8. Then in the later versions, they added the possibility to have aliases that reference aliases. You can do pretty powerful things with that, and awful things as well. You can have infinite recursion of aliases. Don't try that. So you say main ... head. Whatever branch I'm currently standing on, compare that to main, and show me what's new here. Then I can have another alias called missing, where I basically say the opposite thing. What commits don't I have? What commits are not in head, but that are in main? Are you with me? Yeah. So then I'm in a feature branch and say, what do I have? I have this. What am I missing? I'm missing those. I use that all the time. It's like automatic. I don't even think about it. New, missing. Which is the problem when I get to a new computer, where it says get new, unknown command. What? Yeah, and that's the problem. So, you should still use those commands. Okay. Now this is getting into the weeds of Git, obscure stuff. Rebase onto. Now you guys probably know about rebase. Do you know about rebase? Yeah. Now rebase, it does what it says. It changes the base of your branch from one commit to another. Insert you all your base meme here. So what does rebase onto then do? Rebase onto allows you to take a portion of a branch, a sequence of commits, not from the branching point, but somewhere in your branch, take that sequence of commit and transport it into another commit. Change the base of that portion. Now, how is that useful, you might wonder? Well, let me show you. Let's say that we have a situation that looks like this, the usual main topic branch. Now, let's say that we have rewritten this commit over here, which we actually did. We have amended the second to last commit. So we have rewritten that. It becomes a new commit with a new commit hash. However, any topic branch that included that commit before now has a reference to the old one. Are you with me? Yeah. So that B is still present in my current topic branch. Now, what I want to do is that I basically want to take these two commits and I want to move them so that the base becomes main, thus effectively getting rid of that. So this is what I want to do. And I want to do it in one go. I don't want to fiddle around with interactive rebase and stuff. I want to write one command and take C and D, which I know are the new commits, and rebase them on top of main and exclude B. Well, rebase onto, it's exactly what you need for this. And how does it work? The syntax is rebase onto, and then you say, what is the new base? And then, that's the key part, you say, what is the old base? What do you want to replace? Which is different than a regular rebase, which basically gets all the commits from the common parent, from the branching point. So let's try it out. So we are in the feature branch. In our case, we want to say main and B. So we want to say git rebase onto main, right? Rebase it onto the new base, which is the commit currently referenced by main. What is the old base? The old B, which now I realized I forgot to grab the hash of. So let's say git new. By the way, I forgot to show you that this is indeed the case. Can you spot something when I say git new and git missing, something interesting. See here, this is the old, and this is the one we amended, right? Still appears, it's in main, the new one, and our current feature branch as the old one. That's the one we want to get rid of, is this one. So let's grab the commit hash, and then let's say git rebase onto main. What is the old base? It's B. Bam. Let's get git new, and that commit is gone now. Okay? One operation transport a portion of a branch into another branch. Did you guys know about this? Okay, 1 or 2. Do you use it regularly? Yeah? Cool. Because it's very useful to also inside a branch, let's say that you want to remove some commits in the middle. Of course, you can do that with an interactive rebase and then comment them out. But rebase onto is a much faster way to do it. You say, what's the new base commit? That's this. Which is the old base, that, and everything in between is going to be removed. Okay. Rebase onto. Of course, the final result is that we have a linear history. Now, let's switch gears again. Let's talk about the reflog. Do you guys know about the reflog? A couple of you. Okay. So Git is really good at tracking the contents of your files, but it also tracks its own files. And in this case, it tracks the branch references. So you know that in Git, a branch is just a pointer to a commit. Now, what Git does is that every time a branch changes, either you make a new commit, so you move it forward, or you do a reset, you move it to somewhere else, or you do a rebase. Whenever a branch changes, Git records the previous commit that that branch was pointing to into its own log. It's called a reference log, because branches are just references, right? So how do you get to the reflog? Well, you say reflog and then the branch name, because every branch has its own reflog. So for example, I can say git reflog main, and then I get this list where you say that each entry here has the name of the branch, then at, and then a number, which is an index, which increases. So the higher the number, the older the entry in the history is. And of course, the latest one is 0, which is the one we're currently at. And you can see that also it contains what kind of operation it is. So this was a rebase, this was a commit, and this was a reset. Now, how is this useful? You might wonder. Well, before we move on, you should also know, oops, close the presentation. Never type Q when you are doing slides from the terminal, because Q is quit. So let me just get back to this point real quick. There you go. Reminder to self, don't type Q over there, but type it here. So head, which is also a reference, and head, of course, points to the branch you currently have checked out, also has its own reflog, which you get to by saying git reflog without anything. And this is basically the same thing, however, it's for head. Now, what's different between a branch reflog and head's reflog is that, remember, when you change a branch, when you check out a different branch, you are changing head. So head's reflog also includes checkout operations. And how is this useful? It's a little thing, but you can still use it. If I switch to, I say switch, but of course it's checkout. Switch is the new command for that. Switch main, I can say git switch minus, and I get back to the previous one. So you can, thanks to the to head's reflog, you can switch back and forth between two branches, which is the equivalent of saying git switch at -1. So the dash is basically a syntax for saying, you see the head is implicit, so you say at -1, so the current one -1. Okay, pretty useful. But how is the reflog really useful? I mean, the branch reflog. Well, let's say that we have a situation that looks like this. And we have two branches, topic and main. We rebased the topic on top of main, right? Which is what we actually did right now. Now, let's say that we change our minds and we want to go back to how things were before. We want to undo the rebase. However, the rebase is already complete, so there is no way to abort it. It's complete, it's done. How do you get back to the previous commit? The previous commit, of course, is still there, but there is nothing really pointing to it. But is there? Of course, there is one thing that's pointing to it, and that's the reflog. Reflog remembers what commit that branch was pointing to before the rebase. So how do you undo a rebase? Let's switch back to the feature branch. You can always reset, which is the command to move a branch reference to a different commit. And then you say hard because you really mean it. Now you say hard because you also want to change your working directory so it matches that commit, that snapshot. And then you can say feature, add test script, and if you just did the commit, if you didn't do nothing else, you know that's going to be 1, right? Which is the previous entry. So you reset that to the previous one, and if I say git new, now I have my old B commit back. So I effectively undid a rebase. Now, since we are doing so good on time, I have some bonus tips. What if you don't know where to look in the reflog? What if now there are situations where you realize you want to undo a rebase or undo an operation, but it's much later than it actually happened? How do you can you look for stuff in the reflog? The answer, yes. The way you do that, of course, you can use the pickaxe, same command that you used to look in the history of your commits, but you can use the same command to look in the reflog instead. So you can say git log, one line. So in this case, the pretty option doesn't work with the reflog, so know that. If you're gonna spelunk in the reflog, you can use the pretty option. So you say log and then one line, just print one line. And then you can say S, for example. So the pickaxe, let's look for the commit that included the word embarrassing with the 1R. However, I don't want to look in the history. I want to look in the reflog. So I say walk reflogs instead. And now I get all the entries you see from the reflog instead that contain that word. Now, what you also want to do is that if you're going to reset your branch to something, you better reset it to either a start of rebase or even better to a commit. So when you look in the reflog, you want to find basically commits. So what can you do? Well, you can take this output and pipe it to grep and say, I just want to filter commits. Okay? And then if the results are long, you want to be able to scroll up and down, so you pipe it to less. And then you just get the commits that include that word, so the embarrassing with 1R. Now there is another thing. Now, of course, you just get numbers here. They might not tell you, they tell you just how old this entry is, but it might be helpful, right? Okay, this one is much older than this one, but how do I know which one I should reset to? Well, another way to make it easier is that you can include the date instead. So here, I add the date option, and I say local, and now instead of the index, I get the timestamp of the commit. So this information might be easier for you to find in the reflog the commit that include the line that you want to get back to in your branch. And if you don't want to reset your branch to that, you can always create a new branch that points to that commit. So something that I do, for example, let me just grab one of those, is that if I find the commit that I'm interested in, that yes, that is the one I want to reset to, I can grab the commit hash, and then I can just create a new branch called, for example, temp on that commit. And now I can just look at that commit. So I create a new branch that's pointing in a commit that I found in the reflog. Now you might be wondering, how long are things kept around in the reflog? They're not there forever. By default, they're going to be there for 90 days. So entries older than 90 days are going to fall off the reflog. And then there is really nothing pointing to it, because the reflog is the last thing that points to a commit. And once they fall out of the reflog, they're going to be, you guessed it, garbage collected. Because yes, Git has a garbage collector, which you can invoke by saying git gc, another little piece of information for you. But this runs automatically in the background, so you don't have to worry about it. Okay. So what we did is, in this case, we resetted to a commit that we found in the reflog. And we effectively undid our rebase. All right. Last gem, and my favorite one. Rerere. Do you know about rerere? No one. All right. One. Okay. I thought I could get away with. Okay. So I count it as a no then. Perfect. Perfect. Okay. That's actually my favorite one. Rerere. What does it stand for? Can you guess? Now I already moved the slide. It stands for reuse recorded resolution. Makes sense. So, merge conflicts are a fact of life. You're not escaping them, unless you're working by yourself. And even then, you can get a merge conflict with yourself. It happened to me many times. So, and have you ever been in a situation where you have to resolve the same conflict many times? Has it happened? Yeah. Now, when does this happen? Well, one situation where this happens is when you're using a kind of workflow which is called the test merge. So let's say that you are in a topic branch which is long running. You keep this pull request alive for a long time. In the meantime, the main branch is moving along. So if you don't want to fall behind too much, which is always a good idea to not wait too long before you merge, otherwise you're going to have all the conflicts in the world, is that you regularly merge the main branch into your topic branch. Now bear with me. Not the other way around, you merge main into your topic at regular intervals. If main is moving faster on a big team with a lot of churn, you do it maybe once a day. When you do that merge, you're going to have possibly conflicts. If you have rerere enabled, you're going to resolve those conflicts, and Git is going to remember how you resolved them. And then you keep going with more commits, and then you regularly merge down. Now, when you are done, what you want to do is you rebase your topic branch on top of main. Now, this will get rid of all the merge commits, because rebase by default does not preserve merge commits. So all those merges are gone. However, you're going to get all the conflicts again. But since you use the rerere, those will be automatically resolved. Okay, so this workflow that I described for you is very useful in situations where you have long-running topic branches, long-running pull requests, and a fast-moving main branch. Regular merge commits. So how do you use it? Well, the first thing you need to do is enable it, because, of course, it's off by default. And remember that, of course, rerere works in recording only from the point when you enabled it. So all the conflicts that you resolved yesterday, those are not recorded. However, there is a shell script out on GitHub that tries to train the rerere on all the merge conflicts. But it's, I don't know. Just know that it works from when you enable it. Re enabled, config global re enabled true. All right, so now it's on. Now let's try, we have this scenario, let's try to merge topic into main. So let's switch back to main. You see how fast it is with the minus, as long as you're bouncing between two branches. So let's switch to main and let's merge the feature branch. Conflict. Yes, it was planted. So regular conflict, however, you might notice there is a new line in the output, recorded pre-image for this file. So re is active. Now, how do you proceed? You proceed by resolving the conflict as you normally would. No questions there. So the conflict is in index. Of course, it's over here. We have two versions. You could choose just one version, of course, or the other, but I'm going to edit it manually. Let's get rid of this. Let's get rid of that. Actually, let's get rid of that and that. So we basically want to keep the version with the addends, which is the one we want to keep. So resolve the conflict, save and exit. So now we add this to the index. We stage it, which is telling it that, yes, I have resolved the conflict. This version that I've staged is the resolved one. And then I can say git merge continue. Bam. Now I have resolved the conflict, and notice here, recorded resolution for this file. Now, let's say that we change our mind again, and we want to rebase instead. Instead of creating a merge commit, we want to rebase. So we are on the main branch still. Let's undo the latest commit by resetting to the previous one. No need to use the reflog in this case, because the commit is still there. So I just reset to the previous commit before the merge commit. And now there is no merge anymore. Now let's switch to the topic branch. And now let's do a rebase on top of main instead. Okay? Now, of course, a rebase is still a formal merge. However, instead of merging two commits, you are applying one commit one at a time. But the conflicts, if they're there, you're still going to get them. You're going to get them just when it comes to that commit. So, of course, you're going to get the same. However, you see here, special line, resolved using previous resolution. Now you might wonder, why didn't it just do the thing? Why do I have to look at it? Well, because things change, and a resolution that you applied earlier might not be valid now. Remember that these resolutions have been recorded for a long time. So Git gives you the chance to look at it and say, hey, I applied the solution from earlier, but does it still look good? So in this case, we just have to look at the file and say, yes, it looks like the resolution we did earlier. It's using the addends. Now I might want to run some tests to see that it didn't break anything. Yes, works. So now how do I tell that I still want to keep that resolution? I just add it to the index. Now, what if the resolution is no longer valid? In that case, I would say git forget index. And then it's going to basically remove the previous resolution for that file. Because the way works is that it remembers, based on the file path, if each side of the conflict looks exactly the same as when you resolved it, then it's going to apply the final file that you used. And by saying forget, you're basically removing those files. But in this case, I just want to add it. And then I say rebase continue. and I'm done. Okay? So that's the essence of re. Let's wrap this up. We have been looking at 9 gems. Why 9? Because they fit pretty nicely, as you'll see soon. Pretty logs use the pretty option to customize the output over the log command and then write an alias so that you can use it quickly. Pretty diffs use delta to format the output of the diff command so that you can have syntax highlighting and it's easier to navigate and it's better on the eyes. Staging, we've been looking at how to partially stage a file using the patch option of git add. And then we've also looked at how to use the stash keep index command to isolate what you have staged so that you can verify that it doesn't break the build. We looked at searching, pickaxe, -s, find commit that either add or remove a line that matches a pattern. And by the way, if you're into regular expressions, you can say -G instead, and then you can write a full regexp to find the matches. We looked at automation, auto squash, and auto stash. Auto squash allows you to speed up the workflow where you amend the previous commits by doing one single interactive rebase. And auto stash, you can do a rebase even though you have changes in your working directory. The dot notation, more specifically the dot notation, to compare branches, what's in my current topic branch that is not in the main line and vice versa, and have aliases for those as well. We looked at rebase onto, how you transport portion of a branch from one branch to another instead of transporting the entire branch. So doing branch surgery, so to speak, within portions, rebase onto. We looked at the reflog, Git's universal undo machine. We can find commits that you thought were lost, but they're still being referenced by the reflog. And bonus tip, how to look for stuff in the reflog using the pickaxe and the walk reflogs option. And last but not least, reuse recorded resolutions. Now, there is much more than this in Git, as you can imagine. A lot more. So if you have Pluralsight, I have a course out called Advanced Git Tips and Tricks, where you will find these things and much more stuff that Git has inside its inner workings that can and will improve your daily workflow if you make them part of your toolbox. And with that, thank you.